In this video, I will demonstrate how to use matrix multiplication to optimize a portfolio for any number of assets. I will use the example from quiz 3 because that's the problem that we're familiar with right now. I've laid out the steps, and I've laid out a very detailed template that you can just fill in for the homework. As we get more and more practice with this, we'll make the template less and less detailed, and eventually you'll be able to do this on a blank spreadsheet. But for starters, let's do this on this template that we're filling in to make it more clear. Step 1 says to calculate the returns using the formulas that we've always used. And then calculate the standard deviation and the mean of those returns for each stock. And I've already put this chart on here that as we fill in the data, it will pop up on the chart. The first thing you see pop up is the point for Kellogg stock and ExxonMobil stock, where we're plotting portfolio return versus portfolio standard deviation. We know from our prior work that those are going to be the two endpoints of the frontier, and that the efficient frontier will be the top part of that curve. In order to use matrices, we will begin calculating the excess returns. You will recall excess returns are the periodic return minus the average return. We also have a formula for the variance covariance matrix. And since it's an array formula, we need to highlight all 4 cells that it will populate before we enter the array formula. We could choose any of these 4 columns to count. And then to enter it, Control-Shift-Enter. And that's our variance covariance matrix. Next, we need to set up a calculation area where Solver can optimize portfolios for different weights. I'm going to guess 50-50 on weights. The big difference between this approach and the previous approach you've used is instead of specifying one weight and calculating the other, we're going to let Solver optimize both weights. But we want Solver to maintain the constraint that the sum of those weights is equal to 100%. So we have to have a cell to calculate the sum of the weights. The formula for variance in this example is available. It also is an array formula, so we'll need to Control-Shift-Enter. Control-Shift-Enter. And we're going to use the sum product function today to calculate the return. Simply the weighted average of the weights and the returns. Now for any combination of Kellogg and Exxon we put in, we'll calculate a portfolio variance, standard deviation. Now for any combination of these 2 stocks that we enter, we can calculate the risk and the return. We'll do so, and then we'll copy those as values down into the table. The first scenario in the table that I'd like to do is the minimum return portfolio. So we'll go to Solver and tell it that our objective is return. We'd like to minimize that by changing the weights. We're going to have only one constraint, which is that the weights are equal to 100%. When we solve, we should get the combination of these two stocks that gives the lowest return, which of course is just 100% Kellogg. I'm going to paste that below as values, and then we'll go do it again. This time let's get the maximum return. And of course solver gives us 100% ExxonMobil. Now let's get the minimum variance. Our objective now is variance. We want to minimize it by changing the weights and keeping the total weights at 100%. We can copy that and paste it as values. Now we need to fill in some points along this frontier. We have the two endpoints, and we have the minimum variance. Let's pick a point in between at about 5% return. So let's tell solver to minimize the variance by changing the weights, keeping them at 100%. But let's add a constraint that says that the return is equal to about 4.9%. And solve that. We'll take that portfolio, paste it as values. And then let's do the same thing for a couple of other returns. Let's try it at about 11%. And I think probably about 8%. These are just intermediate points that we're calculating to try to fill out the curve. And we're careful to paste them in order of ascending return so that they'll plot nicely on the chart. Now let's see how close we got to the solution that we used in quiz 3. We'll copy that data, paste it onto this chart, and we've confirmed that we can get the same answer for the frontier using this matrix approach as we did using the formulas from quiz 3. In the next video, I will demonstrate how to do this with more than two stocks.